This is example 6.4 from Discovering Design with Chemistry. Sodium bromide and chlorine react to make sodium chloride and bromine. What is the balanced chemical equation? So first let's notice where on the chart we have those different elements. So here's sodium and here's bromine. So sodium bromide is an ionic compound. And in fact, sodium is in the +1 column and bromine is in the -1 column. And so when we put those together, we're going to have sodium bromide. And then it gets put with chlorine, which is a diatomic molecule. I could be putting little symbols after these, like the gas, liquid, stuff like that, but I'm not going to because the problem didn't specifically say what state of matter each of these was in. All right, and then it's going to make sodium chloride. You probably recognize that at this point as table salt. Those are also in the +1 and -1 column, and so when we put those together, we just have sodium chloride, and then we have bromine. And like chlorine, bromine is diatomic, and so it has to have a little 2 after it. Now to balance this, let's just start comparing. So we have sodium, and we have bromine, and we have chlorine. And so for each of these 3 atoms, we're going to compare how many are in the reactants and how many are in the product side. So for sodium, we have 1 here and 1 here. So we have 1 of each of those. For bromine, we have 1 on the left and 2 on the right. And for chlorine, we have 2 on the left and 1 on the right. So let's start by fixing any of them. Because the bromine is the first one on my chart that needs fixing, I'm going to start with that one. So I'm going to put a 2 right here in front of that, which means that my sodium now has 2 and my bromine now has 2. That fixes both of those. On the other side, I now have an imbalance with this top one. And so if I put a 2 in front of where my Na is, that becomes a 2. And notice it's attached to the Cl. So that also becomes a 2, and that in fact fixes the equation. So the balanced equation for this, let's rewrite it so it looks nice, is 2NaBr plus Cl2 yields 2NaCl plus Br2. Alright, let's move on to the next one. The next one said phosphorus pentachloride, a solid, and liquid water react to make liquid phosphoric acid and liquid hydrogen monochloride. So we don't get confused, let's underline the reactants in blue, and let's underline the products in red. Alright, this time they pointed out the solids and the liquids, so we are going to include those in our equation just because they mention it. So phosphorus pentachloride is, we can use the rules of naming to figure out what that one is. So P is phosphorus, and pentachloride means that there are 5 of the chlorine, and they tell us that's a solid, so let's include that. And then we know what water is, and they tell us it's in its liquid state. Alright, and then on the reactant side, we have liquid phosphoric acid, and thankfully they gave us the formula for that. And then hydrogen monochloride, that one again, we can use the naming to know that hydrogen just has 1, and then the chlorine just has 1 because it's monochloride. And they told us that that was liquid, so we'll include that information. So now let's start comparing. Let's make a chart. So we have P, Cl, H, and O's to worry about. So on the left we have 1P, 5Cl, 2H, 1O. And then on the reactant side we have hydrogen is in 2 places, so we're going to have to be careful about this one. So we have 3 plus 1 makes 4. We have 1P, we have 4O, and we have 1Cl. Alright, for this one, we can choose to either work our way straight across, or we can go in any order that makes the most sense. I'm going to start with the P, which is fine. I'm going to move on to the Cl, not fine. So we have 5 on the left, and we have we have 1 on the right. So we're going to change this to a 5, which means that my CL becomes a 5, and my H is also changed. Again, remember, I have 2 places for my H, so I have to be careful about that one. So I have 3 H's plus 5 H's is 8 H's. Okay? The next one down got affected with that one. It did match anyway, so we were going to have to deal with it. So we have 2 hydrogen on the left and 8 on the right. If we multiply the water over here, if we put a 4 in front, then this 2 times 4 makes 8, and the oxygen, which was previously 1, becomes a 4. And if you notice, that fixes it. We can do one last check just to be sure. So let's look at this one more time. So we have 1P, 1P, 5Cl, 5Cl, 8H, and we have 3 plus 5 makes 8 of the H. We have 4O, and we have 4O. Perfect. Everything balances nicely. We can get rid of this extra little scratch I put down here while we were checking things out one more time. So this is our finished balance equation. If we want to write it again more neatly, we can. It doesn't look too bad, so I'm just going to leave it like it is.